A nurse pushes a cart by exerting a force on the handle at a downward angle 35.0 degrees below the horizontal. The loaded cart has a mass of 28.0 kg and the force of friction is 16 newtons. A. Draw free body diagram for the system of interest. Alright, so what are we given? The force is exerted at an angle 35 degrees below. So if you assume the positive x-axis to be the reference point, our theta is going to be downward. That's going to be 35.0 degrees. The mass of the loaded cart is 28 kilograms. All right, and there is a friction force which is 16 newtons. Friction always opposes the applied or the exerted force. All right, so what are we asked to find in A? Free body diagram. Draw free body diagram. So A is asking for free body diagram, FBD. All right. So if we assume our target or our interest is the cart, the loaded cart, this point here, then if this is the positive x-axis, the force will be exerted in this direction. So this will be theta. The force exerted will be this one here. All right, and then there will be a friction force which opposes the applied force. Okay. What other forces do we have? We have mg downward. Now, notice we have the component of F in the vertical direction as well. And there is no motion in the vertical direction. Therefore, there will be a normal force exerted by the floor on the cart. That will be upward. Normal force is equal to, in magnitude, equal to mg plus the vertical component of F. So this is a free body diagram. Now B, what force must the nurse exert to move at a constant velocity? The term constant velocity is important here. V says constant. Velocity is constant. And what does that imply? When the velocity is constant, acceleration is equal to 0. And what does acceleration 0 means? The net force is going to be 0. F net is going to be 0. And what we are asked to find is what is the force exerted by the nurse. Alright, so if F net is equal to 0, then the force component of the exerted force minus the friction force, which is opposite to the direction of the exerted force, must be equal to 0. Alright, so what is the force in the x direction? The force in the x direction is this component here. That's equal to F cos theta. So F cos theta minus F is equal to 0. That implies F cos theta is equal to the friction force in magnitude. Therefore, F is going to be F over cos theta. All right, so we know the friction force is 60.0 newtons divided by the cosine of the angle, cosine of negative 35.0 degrees. And that's equal to 73.2 newtons.